All right, hi everybody. Welcome to your video lesson for Unit 8.1. Today we are beginning our work with quadratic functions. Okay, so the first thing we're going to do is talk about all of the characteristics of a quadratic and how to find them, and then we're going to put it all together and start to graph and solve for the roots of a function. So a quadratic function, an equation, comes in the form of ax squared plus bx plus c. So ax squared is the quadratic term because it has an exponent of 2. Bx is the linear term because technically that variable has an exponent of 1. And c is the constant term. That's going to be just a number. So the graph of a quadratic is called a parabola. So it takes the shape of a U. Okay, so please make sure that when we graph these in a few minutes, that the bottom or the top, depending on the way that your parabola opens, is curved and smooth and it does not come to a point. Okay, so you see the parabola in green opens up. That's a positive parabola. That means that the a value in your equation, the ax squared, is a positive number. The red parabola is opening down. That is a negative. That means that the a in your ax squared is a negative number. So just by looking at the function, which is the equation, we could tell which direction our parabola is going to open. So the next characteristic of a parabola is called the axis of symmetry. So the axis of symmetry is an imaginary vertical line that intersects the x-axis through the middle point of the parabola, and it creates two symmetrical halves, hence axis of symmetry. Now if it's a vertical line, we've studied vertical lines a lot so far this year. A vertical line has an equation of x equals a number, and that's how we're going to state our axis of symmetry. So if here's my parabola, we were looking for the middle where two symmetrical halves would be. It would be that dotted blue line, and when we graph parabolas, we indicate the axis of symmetry on the graph by including a dotted vertical line. The equation there is x equals 2. We can't just say 2 because that doesn't indicate a vertical line. When we're finding the axis of symmetry, we're going to use a formula. Very important that this is included in your notes. So the formula is x equals the opposite of b. Okay, so we know that when we have a negative, this means opposite. So the opposite sign of the b value from your equation all over 2 times the a value. So you always want to make sure that you start with that equation. Without that, we can get nowhere when trying to graph a parabola. So the axis of symmetry leads us into the vertex because they are related. So the vertex is the most upper or the most lower point of the parabola. So the highest or the lowest point, depending on the direction that it opens. The vertex is an ordered pair, so you must write it as an xy value. So think for a moment, how are the x-axis and the vertex related? So if I show you this graph, the vertex is that red ordered pair. And we saw the axis of symmetry before, that cuts through the middle of the parabola. So why will the axis of symmetry and the vertex share the same point? Because the vertex lies on the axis of symmetry. So remember that dotted blue line that was in our graph in the previous slide. This ordered pair sits on that line. So they are at the same x value. So that means when we go to find our vertex, we're going to use the value from the axis of symmetry and carry that in to the next step of our problem. So once we have an axis of symmetry and a table of and a vertex, okay, and I'm going to show you how to actually find these in a few minutes, we're then going to use that to create a table of values. So typically with a table of values, we use -2 to +2, but for a parabola, it's all going to depend on the vertex. So we're going to put the vertex in the middle of our table. So let's say that our vertex is 1, -7. When we create our table, 1, -7 is going to be the middle of those 5 points. And then we're going to go up 2 x values and we're going to go down 2 x values to fill in. So it might not go from -2 to +2 anymore. Okay, it's going to shift around the graph depending on where the vertex is. We'll then fill in the table for the rest of the function and we'll get out our y values so that we have ordered pairs to plot. Okay, the next piece of information that we want to include on the graph of a parabola is the y-intercept. We've worked with y-intercept before. We know this is the point where the graph intersects the y-axis. Okay, and the way that we find that is the same. We're going to set x equal to 0 and solve. Okay, now we can also take a shortcut. So if we see here, when we plug in 0 for x, okay, we can see how these first two terms cancel out and we're just left with the c value. So we can also say that the y-intercept is the ordered pair of 0, c, and c comes from ax squared plus bx plus c, which was in the equation of the function. Okay, but you always want to make sure that you are stating the y-intercept as an ordered pair. Okay, next we have the roots. So the roots are when we solve the quadratic equation by graphing. Okay, so there's graph the parabola and then there's solve by graphing. And solve by graphing means you want to use the parabola, use the graph of the function to determine where the roots are. Okay, the roots or the zeros, those words mean the same thing, are the points where the parabola crosses the x-axis. So those values, when plugged into the function, would make it equal 0. Now, in order to solve by graphing, you have to first make sure that the equation is equal to 0. In order to even do the graphing process, the equation has to be set equal to 0. So that just means getting all of the terms to the same side of the equation. Okay, the very last component here, the characteristic, before we get into graphing, is the minimum and maximum values. So the y value from the vertex, it's very specific because remember the vertex is the highest or the lowest point of the function. So the y value from the vertex is the minimum or the maximum, depending on which way the parabola opens. Okay, so if the parabola has a ceiling, meaning that it opens down, like the red graph on the left, then you're going to have a maximum value. Okay, because the vertex would be the highest point on the graph. The highest point equates to a maximum. On the green parabola, you would have a minimum. Okay, the parabola opens up, so the vertex is at the bottom, meaning there are no points that are lower than the vertex of the graph, meaning that's the lowest. Lowest means minimum. Okay, and when you state the minimum or the maximum, again, it's the y value, so we say y equals. Okay, and we're going to go through all of this, and I'll show you the proper way to state your answer as we go through some graphs. Okay.